So now I'm going to discuss about different types of problems you're going to see in this particular topic. So the very first topic is known as, find the HCF. Find the HCF and factorize. The very first basic method what we use to factorize. Okay. Always remember that factorization in algebra is just opposite to multiplication. Remember? Okay. So for example, if I may take, right, when you have something called x plus 3 whole square, what you used to do in multiplication, you used to write this one as x plus 3 times x plus 3, right? This is how you used to write. These are the factors of this one, but when you expand this, what do you get? You get, let's do it and see. So you'll get x square plus 3x plus 3x plus 9. Look at it. So this was the expression. This is the expression for which the factors are these two. So that is what we are going to do. When you did multiplication, right, you used to always multiply two expressions and used to get this value. Now you're doing the reverse. You will be given this one and you need to go back and find the factors of this one. Okay, let's look at a couple of examples to understand how do you use HCF and factorize these expressions. For example, you have the first expression as 25ab square minus 15a square b square. You want to break them into two factors. How are you going to do it? So the very first method, what you need to do is that take this first term, right? You'll write it like this, 25abc square. How can I basically break it down into factors? Can I write 25 as 5 into 5? I am covered with 25. There is only one a, there is only one b, and there are a couple of c's. So can I write like this? Done. I have broken down into prime factors if you look at it, right? Now similarly, I'm going to take the second one, 15a square, b square, c square. So 15 is nothing but 5 times 3. A, there are two a's over here, I'm going to write it 2. There are two b's over there, I'm going to write 2 b's, and similarly there are 3 c's over here. Now look at it. How can you find the highest common factor between these two terms? The way we used to do it in arithmetic, can I do the same thing? Look at it. This is one of the factors which is common. This is one of the factor which is common. This is one of the factor which is common, and this is one of the factor which is common. So let's identify the HCF first. So you have a 5 times A times B times C. So that is nothing but it can be written as like this, 5ABC. That's the highest common factor. Now the next step what you need to do is that you need to divide these terms by that one. Look at it. So if I put the expression, your expression was 25abc square minus 15a square b square c square. So when you basically divide it with 5abc, right? 5abc here like this. If you put it, when you are dividing it, right, what do you need to do? You need to multiply it in the numerator also for both of them. This is how you need to put it. That's the factor which you are taking it out. So what happens? This c gets cancelled, this b gets cancelled, this gets cancelled, this gets cancelled. Okay. Similarly, this becomes 3. A gets cancelled, B gets cancelled, C get. So what are you left with? You are left with 5ABC, which is the highest common factor which you have taken it out, and inside what are you left with? You left with a 5 over here. AB got cancelled, you are left with only C, minus you are left with a 3 over here, and you are left with ABC. Look at it. So those are the two factors for this particular problem. I hope this makes sense, right? Now, when you're doing algebra, right, this process might be very cumbersome. You don't normally use this process because if you go to the second problem, right, this will take a long time to do that. So normally what we do is that we look at the expression and see that what is common between these three numbers, what I can take out. Okay, for example, if you look at all these three numbers, right, can I take a 3 out? 3 is common, 3 into 9, 2 into 9, sorry, it is, sorry, not 3, let's say, yeah, it is 3, it will be 3 only, 3 9s are, 3 6s are, and then 3 15s are, if you look at it. Okay, I took a 3 out, and when you look at A, just look at A, what can I take out? You need to look at the smallest one. There is A square over here, there is A cube. So I can take a square common out, right? And then now look at B. What can I do? B cube is common in all three. So can I take B cube out? So now start the bracket. What is left over here? So you took a 3 out. So you are left with a 9 over here, right? You took A square out over here. So you are left with the A over here. B cube, you have taken it out, nothing is left. Now, 3 6 is 18, you took 3 out from here, 6 is remaining, 3 into 6 should be 18. You took A square out and B cube out, so there is nothing left over here in the variable, okay. Now, minus 15, what are you left with over here? Sorry, it is not 15, it will be 25. It is 25, right? You are left with 25 because 3 times 25 will give you 75. You have taken A square out, so you are left with A over here. Look at it. That is what you have. Okay. Now look at it. In this one, can you simplify it further? Because you have a 9A and you have a 25A. These two are like terms, so you should be able to resolve this. What do you get? 3A square B cube times, this is 9A minus 25A will give you minus 16A. Look at it, minus 16A minus 6. Now if you look at it, I have something more common over here which I can take it out. I have a minus common, right? And I have a 2 common between these two. So I can write it as, I'll take this minus completely out and then I'll take another 2 from here. So 2 into 3 will become 6. A square B cube, and this will become, since I've taken the minus out, it will become a plus, it will become 8A minus 3. That's your answer. Okay, let's look at one more over here. If you look at this expression, right, the moment you see this one, it looks a little bit scary, right? But don't worry about it. Whenever you get big expressions like this, right, large expressions like this, you need to find out the pattern and ensure that that expression can be substituted by something else so that your life becomes easy. So look at it. If you look at this expression and this expression, they are common. They are all same. The only thing is that this is looking a little bit different, but here what you need to do is that you need to just move this minus outside. Look at it. Okay, can I write this like this? I'll write it like this, x times x square, because see, this one and this one are same, okay, and this looks similar, but we need to convert into this particular format, okay. So I'm going to write the same thing over here, minus z square. What I'm going to do is that here from this expression, I'm going to take a minus common. I'll take minus outside. If I take a minus outside, if it comes outside, minus times plus will give you minus over here. And what will this become? Whatever you have over here, it will be reversed. It will become x square. It will become a plus. This will become a plus and this will become a minus. Look at it. I just changed it and made it similar to this one by a simple operation. I just took minus out from here. Then followed by z times x square plus y square minus z square. Now what is common in all three terms? There are three terms over here. What is common? The common term is this one. Pull that out. X square plus y square minus z square times what is left over here. You are left with x because this you took it out. You are left with a y over here and you are left with a z over here. look at it. You broke them down into two different factors. So when you look at the expression initially, it may look scary, but if you can find a pattern, right, your problem solution, the solution to the problem becomes very simple.